All right, let's jump right in. We're going to decode the hidden language of the internet. You know, it's this system of secret codes flying back and forth every single time you click on something. And honestly, understanding them is absolutely crucial for anyone who's building or just trying to fix things on the modern web.
I mean, just stop and think about the sheer scale of it all. Millions of requests are firing off every single second. Now, if every server had to completely process every single one of those requests, read the whole email, load the entire image, just to see if it could, the web would just grind to a halt. It would be chaos. It would totally collapse.
So how does it work? Well, the solution is actually this really elegant shorthand. You can think of it as a kind of semantic contract between your browser and the server. And this whole contract is built on a simple set of 3-digit numbers that basically prevent that chaos by setting really clear expectations for every interaction.
To really get this, we need a good mental model. So for a second, let's forget about all the code and just think about something way simpler. A physical envelope. This one analogy, it's the key to understanding why these codes even exist.
Okay, so here is the official technical definition. An HTTP status code is just a 3-digit integer that a server sends back to your browser to tell you what happened with your request. But, that definition is pretty dry, right? It doesn't really tell you the story.
So, let's go back to our envelope. The status code isn't the message inside. It's the stamp on the outside. It's that piece of metadata that lets your browser decide what to do next without ever having to open the letter. It answers all the important questions, like, should I just wait? Or should I try this again later? And most importantly, did I mess up or did the server mess up?
So first up, let's talk about the 300 series codes. These are basically the traffic controllers of the internet. They're the ones telling your browser to go over there. And trust me, getting these wrong can have some pretty massive consequences. We're talking billion-dollar consequences, especially when it comes to search rankings.
Now, what's really interesting here is the evolution. A 301 redirect, that's the classic. It's how you tell Google, hey, this page is moved forever, so please transfer all its ranking power over to this new one. But here's the problem. It can sometimes accidentally change a POST request, which you use for sending data, like submitting a form, into a simple GET request, which just fetches a page. And that can break your app. So the 308 is the modern, much safer fix. It does that same crucial SEO job, but it guarantees that the original request method is preserved. For something like an API migration, 308 is definitely the way to go.
And here's a common mix-up that's worth clearing up. If you ever see a 307 internal redirect pop up in your developer tools, that message probably isn't even coming from the server. A lot of the time, it's actually a fake code that your own browser is generating because of a security feature called HTST. That stands for HTTPS Strict Transport Security. It's basically your browser catching an insecure request and forcing it to be secure before it even leaves your machine. It's your browser looking out for you.
Okay, so what happens when something actually goes wrong? Well, the most important question is, whose fault is it? And that's exactly what the 400 and 500 level codes are for. They create a very clear blame game between the client, that's your browser, and the server.
Now, this is a huge one. You have to understand the difference between a 401 and a 403. A 401 unauthorized means the server is saying, I have no idea who you are. Please log in. It's an authentication problem. But a 403 forbidden, that's totally different. That means the server is saying, oh, I know exactly who you are. You're logged in, but you just don't have permission to see this page. That's an authorization problem. Mixing these two up can open up some really serious security holes.
And this is just a brilliant example of how engineers debug really complex systems. A 502 bad gateway, that usually means an intermediary server got a response that was just total garbage. The application itself probably crashed. But a 504 gateway timeout means the application is just quiet. It's not responding at all. So that points the finger away from the code and probably towards a slow database or some network issue. See? Two very different problems diagnosed by two different codes.
All right, let's lock these in real quick. 401 is, who are you? 403 is, I know who you are, but nope. 429 is, hey, slow down. And then on the server side, you've got the classic 500, oops, I crashed. And the more polite 503, I'm a little overloaded right now, maybe try again later.
Okay, that was a lot of numbers. So how in the world do you keep them all straight, especially if you're, say, in a high-pressure situation like a job interview? Well, there's a really simple, super effective little memory trick for the 5 main classes of codes. The 100 series codes are all informational. Just think of it as the server saying, hold on. The 200 series, that means everything is a success. The server is basically telling you,
Here you go. The 300 series is for redirection. The message is pretty straightforward. Go away, over there.
The 400 series means there's a client error. So the server is pointing the finger right back at your browser, saying, you messed up.
And finally, the 500 series. That means it's a server error. The server is taking full responsibility, saying, I messed up. It's really as simple as that.
So why did we just spend all this time decoding a bunch of numbers? Because this isn't just some academic exercise. This secret language has real, tangible consequences for businesses, for security, and honestly, for the stability of the entire internet.
You know, using the right redirect code, like that 308 instead of the 301, it protects your search ranking. Properly separating a 401 from a 403 helps prevent attackers from figuring out value usernames on your system. And using a 5.3 code correctly lets systems build in what are called circuit breakers. It's a safety mechanism that automatically cuts off a failing service so it doesn't take down the entire network. This stuff really, really matters.
At the end of the day, these codes form a contract. And when you respect that contract, when you use this language with precision, the web and all the amazing tools built on top of it, from search engines to your monitoring systems, they start to work with you, not against you.
And that kind of leaves us with one final thought. This language, it's been evolving for decades. It's added new words like 103 early hints for performance and 308 for safety. So the question is, as the internet keeps changing, what new words, what new codes will it need to learn to describe the interactions of the future?